Frictionally speaking, number 3. So we have a tank that is driven across the sand with a constant acceleration. The coefficient of friction between the tank and the sand is 0.15. So it's moving, so that's mu k, kinetic friction, 0.15. The net force on the tank is 150 newtons, and the applied force is 900. So the net force, we'll need that later, is 150 newtons. So let's draw our force diagram. We have an applied force, normal force, force of gravity, kinetic friction. The first part of this question asks for, it says, what is the mass and the acceleration of the tank? We will start by just writing out F net x, F net y, and Fa minus kinetic friction equals ma. F net y is n minus Fg, but Fg is mg, so you see the substitution right now. Fg equals mg, so I'm going to substitute that in and then put it in for Fg. So to find the mass, if we look at our x and our y, we really don't see a way yet to find the mass. But we know that the applied force is 900 newtons. And we know that the total net force is 150 newtons. So that means this right here, combination, is equal to 150 newtons. So this is where we're going to go to find the mass. We have 900 minus kinetic friction equals 150. So the kinetic frictional force then is going to be equal to 750 newtons. So how does that allow us to find mass? Well, we know the equation for friction. Friction is mu, and so we get 750 equals mu k times n. But n, from our F net y equation, equals, in this problem, mg. So we get 750 equals 0.15 times m times 9.8. So the mass of our tank is then 750 divided by 0.15 times 9.8, and we get a mass of 510.2 kilograms. So there is our first solution. The second part of this question wants to know, what is the acceleration? So we're looking for A here. Well, now that we know what Fa and Fk are, and we know the mass, we can just solve 900 minus 750 equals 510.2 times A. A is 150, that's the net force right there, we already knew that, 150 newtons divided by 510.2 kilograms. And we get 0.29 meters per second squared. So that is the acceleration of our tank, and here is the mass of our tank. We're going to do number 5 and number 6. So, number 5, there is no friction. It says a 57.2 kilogram crate is placed on an incline of 30 degrees. So, there's my crate. The only forces I have, force of gravity, normal force, there's my angle there, and it wants to know the acceleration. It doesn't give us the mass, but that's okay. When I draw in my axes, that is my y-axis, this becomes my x-axis because the direction of acceleration is down the incline, and we only want acceleration to be in one direction. There is theta there. So we're going to write, as always, our f net x, f net y. So f net x, f net y. I only have one force that's only in one direction. That's the normal force. And my force of gravity is in two directions. We have a small part of it right here in the x direction and a small part of it right here in the y. So in the x, that's going to be mg, went ahead and substituted already, sine of theta equals ma, again ma in the x direction that we called, and this is going to be n minus, and then since I have an mg sine theta, I have to have the cosine part of it in the other direction, may, but y is 0. Okay, as we can see, it says solve for acceleration. So we look at this, and we get mg sine of theta equals ma. Mass cancels out, and a is equal to g sine of theta. So 9.8 times the sine of 30, which is a half. So this becomes 4.9 meters per second squared. All right, we're going to do number 6, which is the same problem, but now there's a coefficient of kinetic friction. So I'm going to add one more force to this diagram here, and that's going to be my kinetic frictional force. So how does that change the f net x, f net y? Well, f net x, it'll still be mg sine of theta, but now it's going to be minus kinetic frictional force equals max. And nothing changes in the y direction, n minus mg cosine of theta, and that's still equal to 0. So we solve for f net x. So we're going to plug in mg sine of theta minus, remember, friction is immune, so that becomes mu k n equals max. Well, n, remember, n comes from the f net y equation. The f net y equation tells us that n equals mg cosine of theta. So I need to substitute that right there. So the equation now is going to look like this. mg sine of theta minus mu k mg cosine of theta equals to ma in the x direction. Mass cancels, so that's good because we still weren't given a mass. And now we can solve for a. A is going to be g sine of theta minus mu k g cosine theta. So 9.8 times the sine of 30 minus 0.34 times 9.8 times the cosine of 30. And when we solve for that, It gives us 2.01 meters per second squared. Hope this helps.